for VAST Data.
Hello, Steve. Thank you.
Hi, everyone, and welcome. Welcome to the webinar entitled What's Next? Like Life After Hadoop and Cloudera. My name is Steve Sarsfield. I'm Director of Product Marketing at Vertica. Welcome to the webinar also, Jason Hammonds, Head of Pre-Sales for EMEA at VAST Data. Hi, Jason.
Hi, Steve. Thanks for having me. Good to be here.
Yeah, this is great. I'm looking forward to this webinar. Today we're going to be talking about some of the challenges that Hadoop-based platforms have in terms of analytics. And the good news is that there are newer alternatives. There are lower cost alternatives, uh, platforms that will give you really increased performance. And so we're going to talk through and go through some of that. Just to handle a little bit of the upfront Q&A, the slides will be available as a PDF, so we'll be mailing those out as a follow-up email. We also will have a Q&A as part of this webinar. So if you think of any question during the webinar, just use the question mark button that's on the right-hand side of your screen. It's at the top. It's not help. It actually is to ask a question, and we'll try to get to them as part of this webinar. We will be recording this webinar as well for later playback. So with that, let's get going on this. Just really briefly, we'll talk about a story about Hadoop architecture that I want to share with you. We'll go into some of the challenges of Hadoop-based architectures, and then talk about some of the new technologies that we have, specifically Vertica and VAST together, with a drill down on Vertica and a drill down on VAST. So let's get right into it. We recently had a customer come to us, and this was a major pharmacy chain. They came to us right around 2020, right around when the vaccine sign up was a big thing. And so people were hitting their website, signing up to get vaccines, signing up for appointments, but they had some major scaling issues. As you can imagine, everyone in the world wanted to get a vaccine in 2020. So they were running up expenses on servers. They were having poor results. So sometimes people would sign up for appointment and show up, and the appointment would be lost. Sometimes there was downtime for the appointment. So they were looking for a new solution that could really handle the new increased volume that came as part of the pandemic. And they came to us to kind of take a look at that. Um, One of the things that we discovered right away is that they were using a Hadoop-based architecture. It was based on Spark. And so Hadoop has really never been good as a data warehouse or a data lakehouse. So they were currently using 278 nodes of Spark in order to try to get all of those appointments signed up for online. We came in, we spec'd it out with Vertica, and we said, well, that's going to take 9 nodes of Vertica. So you can imagine using Spark as a data warehouse or data lakehouse is really not the best of things. Now, let's face it, Spark is really good for a lot of things. It's good for ETL jobs. It's good for moving data. It's good for real-time analysis, but it isn't really that great for a data warehouse or data lake. And so, right tool, right job here, definitely being applied. If you think about how that plays out for your annual cost, here's a company that was spending, 270 instances for EC2 nodes. They were spending about $30,000 per month and $365,000 per year. And we came in, we said to them, well, with 9 instances, we'll give you what you pay in a month, or actually half of what you pay in a month for a year. So we were able to kind of accomplish that reduction of money for them, or reduction of expenditure for them. There's some other complications when you have 270 nodes, though. It's not just about that. It's about the higher bandwidth that you need. So here in this case, they had to specify M5N nodes, which are the more expensive fast nodes that are connected to a faster bandwidth within Amazon. They had to, also, worry about scaling and hitting a limit. Uh, the nodes tend to chat to each other. They tend to go talk back and forth, and so sometimes you'll hit the weakest link in the chain will be that network traffic and the high limits around that. So with 9 nodes, it's not a problem. 278 nodes, or if they doubled their workload and went to 500 nodes, right, it would be a major problem for this. So it's great to see that you need to use the right tool, right job. The second thing that Hadoop has never been really good at, Hadoop-based architectures, is simplicity. And so, there's a ecosystem of multiple applications that tends to complicate it. So you've got HDFS for storage and Kudu and HBase and Impala and Spark and all of these things that have to kind of come together that are in different versions that complicate a lot of things when you manage the Hadoop cluster. So things like installation, things like troubleshooting. If you have a slow running query, how do you find out which one of these applications is really the problem of the slow running query? Is it an HDFS? Do I have to sort of refactor that? Or, is it something with Hive, right? It's really hard to figure out where problems are. Management, elasticity, upgrades are a big problem. I know Jason and I were talking about sort of the whole concept of what do you do when you want to go from 3 nodes to 5 nodes? And it's pretty hard in Hadoop-based architectures in Cloudera, and pretty easy actually with Vertica. With Vertica, essentially, you'd spin up the 5 nodes and switch your workload over very easily to that new workload. So it's pretty easy to spin that up. Again, sharding and partitioning, those are things that are kind of manual in Hadoop-based platforms. Uh, Under Vertica, those are all automated. So when you want to optimize your data queries, it's pretty easy to do. And the biggest one probably is the last bullet here where we have concurrent performance. So a lot of times I run into prospects who can only run 10, maybe 20 queries at once. And there is no workload management per se in many Hadoop-based platforms. So if I am putting in 30, 50 queries at once, chances are there could be even a crash, right? If you try to do that kind of concurrency. With a database that's ACID compliant, that has workload management, you won't run into that problem. We will be able to handle that. We can kind of take and look at the queries and see which ones are and need to be run first and which ones are going to take longer and so on. So you can do that workload management and concurrency very easily in a non-Hadoop based platform. I think what else is kind of making companies rethink Hadoop is this whole new license that they have in Cloudera. So Cloudera, probably the biggest provider of uh, support for Hadoop-based platforms like Spark and so on. And here, as of the end of 2022, you're going to have to pay for extended support. You don't get the free version anymore. You continue with the free version, but not get support at all. Or you can upgrade to the on-premises or public cloud version of the CDP. So again, I think this is kind of causing folks to take a look at what they have and maybe think about whether there's a better system to run their analytics. And we just happen to have one. Really, it's around these technologies that are coming out now today. So what you're probably looking for is a modern analytic platform and modern object storage in order to accomplish some of the things that you're currently doing in Hadoop. So modern analytic platforms, they have this whole concept of separation of compute and storage. And that is where we take and, if you need faster performance, it's pretty easily to add nodes. It's pretty easy to separate the storage from the compute. And if I need more storage, I can do that separately. If I need different types of nodes for different workloads, I can use those as well. There's things like workload isolation, where if I want to run, if marketing wants to run their workloads and data science team wants to run their workloads, and I don't know, data loading, you want to take and load data with various nodes, you can isolate those workloads very simply when you have that separation of compute and storage. And then the ability to deploy anywhere is key. I think to a large extent, Cloudera does have this, but the ability to go to containers or clouds or on premises is super, super important, especially if you want to have your own private cloud. One of the things that we have in our modern data platform, though, is that one installable for easy management. So we don't have that kind of box of knobs. We have one installable allows you to do all of your analytics in one place. And then within that one installable, we have an ever-growing number of functions for geospatial, machine learning, and time series. And then on the object store side, I think there's new technologies available, and Jason's going to talk about this in a sec, but uh, you know, we have the ability to make on-premises look like cloud and cloud look like on-premise. And this whole concept of the S3 API is super, super important. We can centralize all of our storage to fight disparate data. We'll always have a backup. We'll always be failure resistant. It'll always be low cost. And this object storage is getting faster and faster as time goes on. And Jason, again, is probably going to talk about that in his slides. So final slide for me, I think, is that when you combine Vertica and VAST, you do get a really good solution for data warehouse, data lake. Here we can take and store data in VAST, whether it's a data warehouse and that is, our own proprietary data format that's super optimized, or it's a data lake where you're using Orc and Parquet and, external tables, and combining those two things. We allow you to do that. You're storing your data in one place, and then you're analyzing your data with one tool. If you wanted to then take and visualize that data with MicroStrategy or Power BI or Tableau, that's very possible. If you wanted to then use SQL or Python or Jupyter notebooks in order to do some data science around that, that's also possible with this new system. And so this really does provide you with a data lake, a data warehouse. It allows you to do a Hadoop offload, and it really provides great data protection and data recovery as part of this. It is, yeah, one more thing, it is sort of like a simplification as well, right? So in the old system, you would have Spark and Hive and Impala and Yarn and HBase kind of all working together to provide analytics on top of HDFS. And what we're asking you to do is take some of your analytical workloads and move them to Vertica and VAST. And it's a very simple way to take multiple applications and kind of trim them down into one application for analytics. You can keep your formats the same as well. So CSV and text and Orc and Parquet and JSON and Avro, all of those file formats are still valid under this new system. But it's just an easier way to manage your analytics. I will say that for the capabilities of analytics, I mentioned at the beginning that the number of analytical functions is ever increasing. So if you're into geospatial, if you're into time series, if you're into machine learning, if you want to do SQL, Python, or R, all of those are possible within the Vertica platform. We provide in-database machine learning so that you can take that repository data that's sitting in VAST, and then you can apply an XGBoost or a linear regression or logistic regression, k-means, and so on. All of these machine learning algorithms to the data that's sitting in VAST. So you can imagine the power of the scale of the cluster that you have to apply your machine learning algorithms, and then the power of that vast data repository to do this predictive analytics. So it really is a complete platform in terms of the analytics that are provided as part of it. And that's it. This is kind of just a summary of it. I won't read this, but the key thing again with being able to do this is this whole concept of workload isolation. So Vertica and VAST provide that. I can go to a management console and I can spin up separate instances. So a 3-node cluster for data loading, another 3-node cluster for marketing and all the analytics they want. I can set up, my dashboards, high concurrency reporting and analytics with a 5-node cluster. All of those clusters are accessing that same repository of data that's sitting in VAST. It's an S3 bucket, is super, super fast, and we're able to provide, real-time response, best-in-class performance, a system that's built for scale, and really radical savings when it comes to providing analytics. I'll turn it over to you, Jason.
Hey, thank you, Steve. So we built Universal Storage, which is the single data platform that provides high performance, any size and scale for analytics queries. And it's architected to scale to exabytes, with customers deploying hundreds of petabytes today in a single cluster with a roadmap to exabytes. It's also multi-protocol with support for NFS, SMB, and of course, S3 compatible API, which is really great for supporting a wide range of analytics tools and applications across data pipelines. Now, we also have support for accelerated platforms like NVIDIA GPUs, becoming more prevalent in the world of analytics. And most importantly, the storage platform itself really rivals and challenges the economics of archive systems and really disk-based systems in general. Now, what makes all of this possible, and it's unique to VAST, is what we call our disaggregated shared everything architecture. We call it DAYS. You'll see that referred to in a number of slides here. The architecture provides really wide amounts of parallelism and concurrency, which is important for queries and ingest. It's also composable, which helps isolate workloads, gives you guaranteed quality of service, and enables elastic scaling on demand, kind of in a disaggregated, stateless type of architecture. Okay. Now, what I'd like to do is really give you a vast perspective around some of the challenges with Ozone that we feel like we can solve with kind of a more modern architecture. Ozone still uses a server node based shared nothing architecture. Okay. It's sort of a new version of what HDFS really kind of started as in the Google file system and all these other shared nothing systems that you see on the market today. And all of these bring a complexity, in this case, Ozone also brings a complexity of many bolt-on services that really need a lot of careful performance planning, mainly for peak periods, and it really have a lot of knock-on effects and dependencies that limit scale. Okay. Now, for example, here you see S3 gateways are a big part of this solution. And in our experience, S3 gateways bring a lot of limitations. They require very, very careful performance planning, and they're very time consuming in that respect. And they just simply cannot elastically expand up and down on demand, which is obviously what customers are looking for today. And add to that, data copies are still needed across these services. So there's an ongoing effort from IT, and it's required from really a tuning standpoint. It really limits what you can do when it comes to spinning up on-demand services. And then think about data sprawl in a sense that it's still a major challenge. Is CDP think of it on CDP on-prem, it remains a server node shared nothing platform, which needs that 3x replication and generates really a tremendous amount of east-west traffic across the entire storage estate, which can be very overwhelming and requires a lot of meticulous planning to account for. This makes things like, for example, like reindexing, rebuilds, they're all very, very costly when the cluster is under load. And all of these things can contribute to server instability. So here's our perspective. VAST uses this day's architecture with what's called a common element store. And you see this at the bottom, which really gives us the ability to disaggregate the protocol layer and really massively reduce and virtually eliminate the east-west traffic that is the biggest enemy of these shared nothing platforms. And it delivers predictable performance as you scale. So all protocols are equal citizens with equal performance, and it's native performance. VAST doesn't need any gateways, and these native protocols can access any element and have protocol attributes for any way you want to access it. Now, we support POSIX semantics as well as locking, along with higher level functions such as encryption like FIPS 140-2 for regulated data. Okay. And these are the outcomes that our customers typically would see. These are just examples from some of the larger use cases that we are solving today in the multi-petabyte space, mainly when users gain access to a single namespace of all flash. They just stop complaining and trouble tickets virtually disappear and infrastructure really just becomes transparent. There are, of course, massive, I think, savings in terms of soft operational costs that are really unexpected from just eliminating this massive amount of tuning and complexity that IT has become so accustomed to with shared nothing architectures. And then, of course, there is the gravy of having 1/10 the data center space and power. And I'll get on to maybe an example of this later on to kind of show you what that really looks like. It's very, very profound. And then, of course, the thing that the customers like the most, every application, no matter how old or new it is, it just scales. And I/O is effectively future-proof. And you're also, by the way, future-proof for GPU consumption, GPU usage as well. Now, one of the great things that our customers like about this architecture, aside from the cost and all the things that we've talked about at this point, is the performance. As Steve mentioned earlier, we're getting better than 3x in terms of queries being much better than what you'd expect from your favorite public cloud provider. But also, you're getting very predictable performance as you scale in terms of capacity. And we give you plenty of flexibility to make choices on whether you want to scale for capacity or you want to scale for performance. In other words, the classical server node architecture, you're no longer bound to having to build out a certain amount of hardware to achieve a level of performance with a lot of unused capacity. We will license the capacity that you need and allow you to build out for performance at the lowest possible cost, of course. Now, when it comes to unifying what we're doing with data warehouse and data lake, let's talk about that for a minute. Really, I think one of the bigger advantages that our customers are finding today is bringing both of these together under one common architecture, under one namespace. With Vertica as a single unified analytics platform and VAST as a single unified namespace, we support optimized file formats in raw Parquet file format at the same time. And these can be used as data lake or other parts of the pipeline may be storing Parquet, JSON, other file types, et cetera, the ones that Steve mentioned earlier. Vertica can then query in place using external table support. It makes it very, very easy and very seamless. Now, from a data pipeline perspective, a single unified analytics stack also means that data can remain easily accessible within a single place. From data ingest through ETL to data warehousing to integration and reporting and BI tools, VAST and Vertica can really radically simplify and consolidate this analytics stack without creating more complexity and more dependencies across the entire storage estate. So our view really is, why not one platform? Consolidating all of these analytics tools into a single namespace makes tremendous economic sense. This is what you get in something like AWS today. But from a VAST perspective, we can deliver the scale needed to do this sustainably, because disaggregated shared everything with all flash supports really a wide variance of access patterns with very, very high throughput. And where you normally would require careful performance planning with a shared nothing platform, we completely eliminate that, and you just don't have to think about it anymore. For example, time wasted on tuning for file sizes and file placement and elastic scaling and upgrades and things like that completely go away. And this gives you, of course, valuable hours back to the business and valuable hours back to your data engineers. Now, I think one of the really distinct advantages of what we bring when we're doing things at scale is reliability. This is extraordinarily important to enterprises. And let me just talk maybe on a little bit more granular level for a minute. The VAST clusters use N+4 coding, and it can basically reconstruct the data from a lost drive using just 1/4 of the data. And that's really, really important, because it means really only 1/4 of the IOs are needed, and as little as 3% overhead is required from a storage standpoint. And that's really, really important. You'll find with shared nothing architectures, they're going to require between 30 and 40% of overhead. So massive savings, contributes to cost, much better cost, but it also, I think, contributes to better efficiency and much, much faster recoveries. For example, when something fails on VAST, you don't have to read all of the data. We use something called locally decodable codes. And that concept means that the VAST cluster can reconstruct unreadable data from only a local fraction of the total number of data stripes in a protection stripe. Because these locally decodable codes we don't need to read from the entirety of the stripe. So each CPU reads its part on the failed drives, and recovery is very, very fast. So it's basically, you can think of it like a point-in-time recovery from synthetic backups. And then kind of last point to make here before I move on, cache coherency is not needed. Our data structures are atomic and they're crash consistent. And our front-end container layer is very, very resilient. So even through failure, we can preserve 100% uptime and still deliver high performance, which our customers love. And I wanted to wrap up maybe with an example of a customer that we delivered this for. All customers, of course, care about total cost of ownership. We feel like this is really, really important because we want to make all flash simple and affordable for organizations. That's our number one goal. And with universal storage, obviously you're getting all flash, so real-time analytics becomes very, very real in terms of results. Because we're doing this in a single namespace, we're eliminating those costly silos, bringing that efficiency and economics back to a place that's truly competitive, not just with hard drives and these shared nothing platforms that use server node architecture, but even things like public cloud with AWS. So to learn more about this, please contact me and my team. We constantly deliver demos and proof of concept to show how we do this. And we're delighted to do that for you and really show you a contextual TCO on what we can, on the kind of savings that we can deliver for you. So with that, that's pretty much my VAST bit, Steve.
All right, Jason. Yeah, thanks. I appreciate that. That's a really nice look kind of deep dive into what's going on under the covers within VAST, and hopefully we've done the same with Vertica. Though I think we can kind of go different. We can go deeper if we need to. If you need more information, there's some links here that we can provide. We will be sending follow-up information as well, so that will be part of the package that you get as part of at the end of this webinar. I think it's a good time now to go into some questions. So let's do that. Question number one, is there a way to try Vertica and VAST to see how it will do with my analytical workloads? So I think the answer to that is yes, and Jason, you can answer too, but I know for us, if you wanted to try Vertica alone, you can go into our website and download it and use it as part of a trial to make sure that it will handle all the analytics you need. But for Vertica and VAST, I think just reach out to our team. Is that right, Jason?
Yeah, from our perspective, we of course support on-premise proof of concepts. We also support remote proof of concepts from multiple labs that we have resources available from. We also have subject matter experts internal to VAST who know the Vertica very well and can assist you with optimizing your configuration and really seeing and getting the most out of the performance that you want.
Okay, the next question I have here is Vertica or VAST open source? I will say for us, for Vertica, we are not open source, although we do fit in and tend to use products that are in the open source community. So we, for example, a lot of our customers use Kafka and Vertica together because it's a great way to load data into Vertica. A lot of our customers use Spark as an ETL tool and then use that data to load into Vertica. So we do support the open source community. We even have a small fund that we have as part of that. So we hopefully we inspire new projects that help Vertica with our open source fund. And I'm assuming VAST is not open source.
We are not, Steve. That's correct. We are basically, we primarily focus our efforts around engineering for software optimization. And we do some special things on the hardware side to enable, I think, the best, getting more performance out of a smaller footprint. So basically what we do is we wrap what we do from a software perspective around a specific hardware build, and we support it as an appliance. And we deliver an appliance-like experience because our customers really, when they're doing things at scale, they want it to be simple. They don't want the complexities of what's going to, and all of the dependencies of what's going to happen when I do this. And that tends to be kind of one of the pitfalls of open source, is that you introduce way too many variables that aren't tested properly from an engineering standpoint. When you get over a petabyte, it produces a bad customer experience. That's kind of where we've come from, and we want to completely eliminate that. We want it to really keep it simple. So we actually spend a lot of money and time on engineering for all of those dependencies in terms of how we support our software on hardware. And of course, we deliver, I think, a great customer experience. You can find plenty of write-ups about us on Gartner's website. I think Gartner Peer Reviews has a lot of very nice write-ups from our customers about the support experience.
Yeah, we've got some good reviews on peer reviews and G2 as well. So yes, thanks. It's good reminder. Great. Okay, so what kind of performance can I expect if I offload some of my workloads to VAST and Vertica? Do you want to any thoughts on that, Jason?
What kind of? Sorry, can you said you kind of broke up there for me a little bit. Can you repeat that?
What kind of performance can I expect if I offload some of my workloads to VAST and Vertica? I think for us, I mean, the key thing is it depends, right? It's always it depends. One of the things that you can think about is, what kind of performance do you need? And if you need a certain SLA, usually we can provide the hardware or provide the recommendation for you to hit your service level agreement. So if I offload some of my workloads to VAST and Vertica, I think we can expect really good performance. I've seen this whole scenario where you're using an on-premises cloud essentially to be very similar in performance or even slightly better in performance than AWS cloud or one of the other public clouds. So that's the kind of performance that we can expect. I don't know, any further comment on performance?
Yeah, I think so. From our perspective, we're leveraging really high-speed 100 gig NVMe over Fabrics capability, and we're giving our customers, I think, the most amount of choice on how they want to architect within that new dynamic. We allow our customers choice of architecting for IOPS or bandwidth. We allow them to use our disaggregated architecture to I think, gain more efficiency on how they architect for capacity or performance, as I stated earlier. And I think that's really important, because theoretically, we can architect for whatever performance you need. Our limits have not been tested yet. We have customers today. I think our biggest customer today is running 120 petabyte in a single namespace, getting well over 2 terabyte per second of bandwidth, for example. So, the limits are really not there yet, but the optionality is the most important thing. Give us your performance requirement, and we will, I think, deliver all of these services that we talked about earlier. But really, virtually unlimited. But certainly challenge us. We just simply haven't reached the limit yet because no one's brought us anything big enough. But the numbers that I gave you just now, that's kind of our current top line, but we can go much higher if we need to.
Got a couple questions here about competition. So there's one mention of Snowflake, there's a mention of Databricks, which are kind of different competitors, I would say. Snowflake is pretty interesting in that the business model seems to be about taking everything and moving it to the cloud. And so for us, when I think about comparing Snowflake and Vertica, I think about how we're hybrid and Snowflake tends not to be. You can deploy anywhere with Vertica, and it's not really the case yet, at least with Snowflake. They're pretty much cloud only. Databricks is another one, and that was mentioned here as a potential competitor. I think for us too, we've spent a lot of time building out analytical functions for both Snowflake and Databricks. We've got built-in machine learning. We've got time series. We've got geospatial. We've got some features that these analytical functions in the platform that allow us to, do more with a single platform than some of the other competitors in the marketplace. So the ability to deploy anywhere and the ability to do analytics that you couldn't do on some of the other platforms, I think are big differentiators. I don't know. Do you have anything to add on comparisons to Snowflake or Databricks, Jason?
Yeah, I mean, I think the feedback that we get in this space, mostly when we're selling solutions jointly with Vertica,
Hmm.
is that customers want an AWS-like experience on-prem, but they don't want to pay a huge amount of tax for that. There's obviously a big consumption tax. It's very difficult to quantify up front, and you only find out about it later. So we get a lot of customers that are in situations where they want to repatriate a lot of these types of workloads because they're very bandwidth intensive, and their costs end up being much bigger than they expected, and their bandwidth and time to result much lower than they expected. So I think what we aim to do really is not try to, we're obviously, we're developing features that support cloud functionality as sort of a second side, if you will, for maybe DR recovery and some other things. And that's fine. But when it comes to pure time to result and I think pure simplicity, we're really focused on building out the simplest, most efficient single namespace that will give you that AWS-like experience on-prem. I think that's really, really important. That's what customers tell us they want. That's what we can continue to develop this platform to do. Just come to us for a POC and we'll show you how we do it.
Great answer. Thank you. Thank you, Jason. New one just came in. This is a great question, I think. Is Vertica offering any storage part? So or an additional storage is mandatory like S3, VAST. In Cloudera data platform, we are getting storage and workload management in the same box in the same cluster. I will say this, really good question. You can do that with Vertica, and we kind of think of that as the old way of doing things, right? So if you want to have your storage and your compute in the same box, that's fine, but there's some challenges around that, and you're probably seeing this as part of CDP. The ability to scale up and scale down to be super elastic is a challenge. The ability to really do disaster recovery and backups, it's a little bit of a challenge. You want to do sharding, or you need to reshard, or you need to refactor your database at all. It's hard in CDP, and it's hard with the old way of doing that in Vertica too. So this separation of compute and storage is a great way to eliminate all of those problems. You can do the disaster recovery, the backup. It's a great way to make that separation. Listen, if you have workload and you don't think it's going to be very elastic, and it's the same workload and it's going to be the same workload for the next year or so, maybe you use the old way of doing it. But if you have elastic workloads, if you know that things are going to go up and down over the next couple of months, this new way with the separation of compute and storage is a great way to do it. So I don't know. Any further comment on that, Jason? On sort of like
yeah, I think so. Thanks, Steve. Back to my previous statement about that AWS-like experience. A lot of that is speaks to, I think, some of the new methods that customers are building out disaggregated stateless architectures that are running new cloud native applications and maybe running some old legacy applications as well. But the key being that when you do that, all of the state is in the storage architecture, so it becomes much easier to elastically scale up and down your compute infrastructure non-disruptively. When you have a server node architecture, especially one that's designed on shared nothing, there's going to be a lot of migration and pain when you have to scale, in some cases, complete disruption. And customers just don't want disruption anymore. That's also another cloud-like feature we get a lot of. And our feeling on it is using a disaggregated and even stateless containerized approach is really in vogue for a reason. It's very, very effective. It's non-disruptive. It's very cost-effective. And it delivers that AWS-like experience that customers want at a much lower cost and, of course, much, much greater performance.
Yeah, and we were talking about this earlier. There is a question about like what's involved with a major upgrade, right? With this. So let's say I want to go from version 11 to version 12 of Vertica, or I want to go from 3 nodes to 50 nodes because my analytical workload is increasing. So what's involved in sort of like doing that elasticity? I can tell you from the Vertica end, it's pretty simple. What we would do is, we offer you a license for both the production environment and the development environment. So what we would have you do, if you wanted to go from say 3 nodes to 5 nodes in your production environment, is simply spin up a new 5 node cluster, point Vertica at the same data it's been using all along, and boom, you can do your testing in your development environment and eventually switch over to that as your production environment. I think for you, there's some things that you offer as well, right, Jason?
Yeah, I think so. I mean, if I can just add a word, I think doing simple what sounds like simple things, like adding physical nodes, with compute and storage being so tightly coupled, that's actually quite difficult. And what you find are customers get talked into this notion of using virtual private clusters with CDP, and that's actually still complex and not easy to scale. It requires a lot of planning and a lot of over provisioning, a lot of inefficient over provisioning, and scaling down can be really, really difficult. And frankly, what we hear is it's just too complicated and nobody really uses it for that reason. And it's got to be simple. It's got to be usable. From our standpoint, these are the reasons why all flash and low latency fabrics using NVMe are game changers. They're game changers for our customer because not just from a cost perspective, but in the sense that we are providing DAS-like performance using NVMe with shared architecture at a very, very large scale with far better economics.
There's a question here about, yeah, is user count limited by the number of compute nodes? And I think that refers to this sort of specification that's in the CDH that talks about how many users per how many nodes you should have, right? It talks a little bit about concurrency. So is user count limited by number of compute cores? No, it is not limited at all. So in a modern database like Vertica, you have something called workload management, which doesn't exist in every database and every analytical platform out there. So when queries come in, it could be 10 queries, 30 queries, 40,000 queries a day, which one of our customer does, right? Workload management is the thing that kind of saves you there. It says, okay, here's a query, it's coming in. I'm going to can I perform this query now, or do I need to queue it up? And, I need to be able to handle that, wait until the servers have enough, time to kind of handle that queue. So, no, we're really good with concurrency because of some of the built-in workload management features that are part of Vertica. Anything to add on that?
Yeah, I think this is one of those subjects where I would encourage you to ask for a workshop from one of our fantastic solution architects in my team. I think who do a great job of walking customers through a menu of scenarios related to achieving greater performance with, I think, looking at concurrency in a different way. Now, obviously, Vertica enables, I think, a lot more from what you just described, Steve. And I think under the, at the storage layer, there's a number of things that we can do, both from driving higher levels of concurrency for a single client, or driving higher levels of concurrency with thousands and thousands of clients. There's a number of different ways that we do this, but we can give you exponential gains is the short answer, and you won't be limited to limiting each user to a core type scenario. We'll give you a much greater degree of flexibility.
That's great. Thank you, Jason. Yeah, appreciate that. I think we'll take one more question. This is about data ingestion. Do you have your own connectors, or do you use third-party solutions? So yes, we have our own connectors. You could connect virtually any database via ODBC or JDBC. You do a copy into the database. We do have some pretty good Spark connectors and Kafka connectors, right? So Kafka integration, if you will. So if you're doing streaming data or real-time data, you might want to use Kafka along with Vertica in order to kind of ingest all of that data. If you want to do, some of your ETL in Spark and then move that over to the data warehouse, Vertica, we have very good connectors for allowing you to do that. And we have partnerships with companies like Informatica and Talend and a lot of the other ETL tools. So all of that is part of it as well. I don't know if you have anything to add on that, Jason. That seems more like a Vertica question.
I don't have anything to add. Nope.
Yeah.
All good.
Okay.
All good.
Cool. Well, I think that's it. That's all we really have time for right now. Thank you, Jason, for delivering this webinar with me.
Thank you,
It was
Steve.
great, very informative. If you have any questions, again, just feel free to follow up. If there's questions we didn't get to, I'm sure we'll follow up at the end. But for now, that ends this webinar. Thank you very much.
That was a great chat. Thank you, Steve. Everyone, have a good day. Thank you.